Okay, we are now live. Hi everyone, I'm really excited to host Theodore Dounas. Uh, I got to know Theo from second blockchain workshop attended recently, and then in Cadria I saw his presentation on blockchain research work, and then I've been following his work since then, and he has done some amazing research, not along with implementation of blockchain with demos and workflow. So Dr. Theo is a chartered architect and a senior lecturer at Scotland Sutherland School at Robert Gordon University. His research encompasses blockchain, generative and parametric systems with a tight orchestration between design and fabrication. I highly recommend to check out the website Archchain.cc. He has listed and compiled all the great resources which are useful for AEC blockchain workflow. And additionally, he conducts research in design for fabrication and assembly. So without much ado, I will give the virtual stage to Theo. He has some amazing content lined up, and I really want to thank you for taking your time to do this.
It's fantastic to be here. Thank you for having me, Mayur. I'll share the screen and start immediately. Thanks for the great introduction. Okay, it should work. So confirming again, you can read the decentralized architecture and BIM and blockchain. So I'll basically go through essentially the research we have been doing with my dear colleagues Vasen Jabi, the creator of Topologic, and Dr. Davide Lombardi from ExitLU on trying to integrate building information modeling and blockchain. I will hopefully give you a little bit of an adventurous trip with some of the prototypes we have, but at the same time, I think we will end up with more questions than we started with. So it's good to start today with Alan Turing and essentially his creation of the Turing machine. Today is his birthday, and the United Kingdom actually today announced, well, they have announced it for a very long time, but the first 50-pound note with his face was circulating today for the first time. And because a lot of the things we will be discussing on blockchain and computation will be really closely related to what Turing has done, I thought I would start with this one. The second one that I think is second point I think that you should all take is a really great quote from the Matrix, which basically says, "Buckle your seatbelt, Dorothy, because Kansas is going bye-bye." And part of the reason why I use this quote is because blockchain in certain cases is so different to whatever you might have encountered in terms of computation and computing systems. More so if you try to combine it with design, where design is a really centralized activity. It's an activity that actually condenses space, condenses matter, condenses efforts compared to what blockchain is doing. So keep an eye, an open mind on some of the questions we will be having this here. But also on a more philosophical level, I will quote Frank Herbert in Dune, where in the whole kind of discussion for the novel of Dune, we are presented with the idea that mechanical and electronic computers have been banned, and essentially they use human machines, human computers to do most of the computation. And part of that has to do with freedom and being able to do a lot of things that are not easier with electronic computers. So I'd like to have, you know, at the back of our minds, this idea that what we are trying to explore with blockchain in design has to do with freedom in terms of the open source nature of it, but also the peer-to-peer nature of it. So it's not just the code being open source, but also the infrastructure being as democratic and as free as possible. But what is a blockchain, right? So let's start with that. It was created first as a concept on the white paper for Bitcoin by a person or a group of persons called Satoshi Nakamoto. And it describes essentially a network of computers who hold each node on the network holds essentially the same ledger of information. So you don't have any kind of centralized infrastructure or any kind of infrastructure where you need to trust central servers, but it is the whole network essentially holding a copy of the information. And the brilliance of the Bitcoin white paper is that it establishes a kind of computational competition between certain nodes on how to establish what is the truth and a synchronization between the nodes. So to give a very simple example, right, if you go and buy a coffee latte with your bank card, essentially what happens is the machine where you put the card in asks the bank whether you have enough money in your account, right, and that is transacted through a central server, right? You trust the central authority about what the truth is, right, whether you have any money or not. And when the transaction is going to go through, right, they will deduct money from your account and they will put it to the account of the seller of the coffee. Now, the way blockchain works is instead of having to have one central server or one bank, essentially you have the whole network that you need to ask, you know, does that account hold enough currency to transact that transaction? And if you lose, say, 49% of the network, you won't have a problem because the network will still be alive. So certain, so that's how it works in terms of being different from a centralized authority, right? The way it then works in terms of participation is that the nodes are in competition between them to generate the next set of transactions. And that's what we call essentially mining cryptocurrency in Bitcoin parlance. However, if we go a little bit lower in terms of its protocol, just to see what the nature of how information is hosted on the blockchain, we will see essentially literally a chain of blocks with each block containing a trance of transactions that are cryptographically essentially reduced into a root by using what is called a Merkle root algorithm. This is what you see in the middle. Then you have essentially each block contains the previous hash of the previous block in the sequence until block number 0, right, which was the first one. It contains also a number used only once, which is called the nonce, and a timestamp. So at each point when you examine the blockchain, right, you can essentially retrieve a block, see when those transactions took place, and you cannot essentially go back and tamper with it, essentially because each block contains the cryptographic hash, the cryptographic identity of the previous block. And that is what brings us to the second fascinating property for blockchains, which is immutability, right? So you cannot go back and change all of this unless you control 51% of the nodes on the network, which is practically impossible. I mean, we can go into a lot of discussion on how you could achieve it, right? But it's essentially very difficult to do so. The diagram also shows what happens with the competing blocks. So every couple of minutes, essentially the competing nodes that want to mine some of the cryptocurrency are trying to compute their own kind of version of the next block. Those that lose, essentially those blocks are being thrown away and only one survives in the end. And essentially the machine that gets elected to mine, to write that block, gets rewarded with cryptocurrency. And that is the third property that is important here, which is incentives, right? So that brings us to another level of creating computer networks that do not work just from the point of view of a central authority, but you get incentives for participation and for good behavior, right? So we'll see a couple of algorithms later on where there is no competition per se, but there is a disincentivization for lying or messing about with the network. So I'll take you to Ethereum then, and this is a representation of what the how you have essentially the competition of proof of work taking place, so that you elect to create the next block. You have here 3 nodes, and each node essentially is taking the number used only once, which is increased by 1. It takes the previous header of the block, which is cryptographically then hashed, and this is then translated into a 128-byte mix and compared with the pre-selected target from the algorithm, right? If you are really close to it or you actually hit the target, you get elected to mine the next block and everybody else loses essentially. So on a very simple basis, this is how proof of work algorithms work. Ethereum doesn't use any kind of special equipment compared to Bitcoin, which do have special computers for mining, essentially because the algorithm has become really difficult every certain period of time. Usually you make the algorithm a little bit more difficult so that you incentivize and make the competition a little bit more fair compared to someone having a lot of computing power. And this is what has driven for Ethereum, has driven the prices of graphics cards really high globally, essentially because people buy graphics cards to mine Ethereum compared to actually doing any kind of useful work for it. So you might hear, in a sense, a lot of criticisms for those aspects. But this is where we go now towards essentially a proof of stake algorithm, and this is where Ethereum version 2 is headed, where you don't have to mine cryptocurrencies by using a complicated algorithm, but you go into a participation and an incentivization of the network with a proof of stake. So what you do is you take a certain number of cryptocurrencies and you lock them on your node, and that's how then your node participates into the network. If you try to mess about with the consensus algorithms, then you will get your stake slashed. So it works as a disincentivization on one level, but if you get elected to mine the next block, you get awarded cryptocurrencies. But the beauty of blockchain now is, because we've talked so far in terms of the infrastructure, right? You have a resilient infrastructure, incentivized and trustworthy, right? It's immutable. But the beauty of it is that once you're able to do subtractions and additions, you realize that you have a basic computing machine on it, right? And this is what the creator of Ethereum asked at some point in 2014 with Ethereum to say, well, if I can do subtraction and addition, then I can do also multiplication and division, and that's basically a computer. So why not being able to run code on it? And they came up with the concept, well, they transferred the concept of a smart contract onto the blockchain, which is code essentially that runs directly on the network. The concept of a smart contract was created first in the 90s by another cryptographer and computer scientist called Nick Szabo, who kind of described the concept of a code that gets executed with the same kind of legal authority that a contract by law would have. And back then, Szabo was kind of describing that as code that gets executed automatically on a certain level of machinery. So what we have for the first time with Ethereum is essentially a global computer, and this is what is the beauty of it, right? You have a network that you don't need to ask permission to run code on it. You don't need to ask people to onboard them for them to participate and so on and so forth, right? And theoretically, whatever you can do with a normal computer, with a normal server to do architecture, right? If you take that from that point of view, or engineering, you can do with this one. There are a couple of problems, of course. The first one is that you essentially have a really high level of penalties in terms of the resources the computer has. And you cannot store a lot of things on it essentially because it's expensive, and we'll see how that happens. But you see here the visualization of the Ethereum blockchain back in 2018, and how you get essentially each one of the yellow dots represents an address, more or less, and some of the blue parts that you see there with documents represent a smart contract. So you get in Ethereum two kinds of addresses. One is the address of theoretically a normal account, so a person doing something, or you get an address from a smart contract, which would represent code on the machine, on the Ethereum machine. And then you see a little bit more that there is a difference in terms of how each of the blocks gets created and how they connect to the miners. I won't go too much into depth here. I'll just take you back to Turing, just to say that as a computer, right, the Ethereum virtual machine, which is the code that every Ethereum node runs, is Turing complete. And essentially that means that you can simulate with it any other kind of computer, first of all, which is the principle of the Turing machines. But also we do not know whether a computation will terminate just by looking at the algorithm, right? So you might have a computation that would take an infinite amount of time, thus wasting resources. So we need a way to terminate a computation, exactly as Turing predicted almost 80 years ago. Hence, for Ethereum, they introduced the concept of gas for computation execution. So to actually use the machine, you need to kind of pay gas for a computation. And literally, if you don't have enough, it will run out of gas. If you have enough, the rest is going to be returned to you. So you use that kind of special kind of cryptocurrency to do it. So what are smart contracts on a low level, right? There are software that executes on the Ethereum blockchain automatically. They are essentially the closest one you can think of in terms of computer languages are classes of code, right? So you will, if you ever done any kind of C or Python coding, they're not complete software from my point of view. So they're classes that you need to kind of chain together. And essentially, from a programmatic perspective, right, this is a digital protocol intended to facilitate, verify and enforce the performance of a contract. And you can essentially have credible transactions without intermediaries or third-party guarantees. On a software level, this is the equivalent of an automated vending machine. So if you can imagine that you have a smart contract that every time you're going to put a coin in, it will execute again and again the same kind of behavior. That's what you want conceptually. So, and with smart contracts on the back end and a web interface or any other kind of desktop interface, and at least the ones we're using at the moment are desktop interfaces and web interfaces, you can create what we call decentralized applications. So applications that do not need a central infrastructure or a central logic. They inherit all of the properties of the blockchain. So they are immutable, they're trustworthy, and they can be used as incentives. So you get essentially examples of decentralized finance, which is one of the most widely used ones. Examples of this would mean for in particular examples, people who don't have bank accounts in large parts of the world are able to actually use it and receive a loan, even without needing to go through the kind of classic problems of the central banking system. You can create really unique peer-to-peer finance objects with it, from people paying their mortgage early on to being able to use cryptocurrencies to create functional tokens, and we'll see some examples later on. But also, you can also create whole organizations that use the smart contracts to run, right? This is what we call a decentralized autonomous organization. Examples of these software code would be through DAO Stack and Aragon. These are the two most known examples for kind of classical DAOs. You can also find other DAOs that are more focused on decentralized finance. You can create fungible tokens, right? These are the closer equivalent to fiat currency, right? So, you know, a pound is exchangeable, is fungible and exchangeable with another pound. But that also introduces the idea of non-fungible tokens, which the closest concept I can explain it with is kind of like a license plate for a particular object, whether that's digital or physical. So, for example, artwork secured on the blockchain, which you can create it and then you can pass it on to the next person. Blockchains are extremely good for traceability problems in the supply chain, right? So being able to find origin of a particular product or material. But also this helps with problems of waste in supply chains and so forth. You can also create any kind of combination of escrow accounts and legal contracts, which are enforceable through smart contracts, or potentially games that use a combination of the above, right? So the most famous one is CryptoPunks and CryptoKitties, where non-fungible tokens are used not only as a token on themselves, but kind of like a virtual Tamagotchi. You can actually interact with a token, and they can give birth to new ones if you combine them. Sorry, let me go back. So what kind of examples do we have of DAPPS in the architectural, engineering, and construction industry, right? So you can have essentially the concept of a DAO, where you can use smart contracts to organize a company, would design, construct, and operate buildings. We don't have yet an example of that, but the global community is researching ways to do that. So when I say we don't have an example, we don't have an actual company yet being run as a DAO. You can have decentralized design applications, and we'll see some examples later on in this presentation. The blockchain would have also a really particular connection with digital twins, more so if these are digital twins that have an importance as infrastructure, right? So from nuclear power stations to airports to train stations, where you really want and need the resiliency of the digital system that operates the digital twin to have the same kind of resiliency as a civil infrastructure of that kind of importance. You can have the plantoid is a kind of more classical example I give of a digital twin, where you have a physical object and you have a smart contract regulating that physical object. These are more like an artwork at the moment, but I don't see the kind of difference of what you would have if you had, instead of a metal plant as a plantoid, you would have a building being operated by a smart contract with the same kind of resiliency and immutability and incentives as on the classic blockchain. And of course, NFTs, which I'm fascinated with because of the potential they bring for circular economy. and of course, supply chain and escrow accounts and so on and so forth. So going a little bit forward now to kind of see what we're talking about with a more classic application of in the IAC industry, right? The way we've framed our research is by looking at the industry and understanding that there are certain problems digital design and the industry itself have been trying to solve for a very long time. BIM used to be part of the answer, part of the solution to the fragmentation and lack of productivity that the IAC industry has. We don't believe that BIM has solved the problem of fragmentation and lack of productivity. It might have made things worse in a sense. There are obviously there is obviously progress compared to what we had 20 or 30 years ago, but we believe still that the same kind of problems that BIM was invented to solve still remain in a large part of the construction industry, the ag industry, irrespective of whether we're discussing of problems in a developed country or in a developing country. I would say the problems of adversarial behavior in developed countries might be worse than developing countries, mainly because they've also developed countries have a developed legal system as well that is very effective, and that is potentially what might bring these into the fore. I see a question in terms of the completion execution of clauses within smart contracts. So I'll give examples later on, so you'll see examples of what that might mean. But taking us to the beginning of how we started working on this, we participated in a competition for the design of a new city in China, right when I was moving from China to Scotland, and at that point, we were testing an algorithm that I had created using cellular automata to create density, increased density of tall buildings in Suzhou in China. We wanted to take part of that algorithm and create more densities at the city level. And we found that that competition to create a new city was a good opportunity for us to kind of try to design a city algorithmically by using density algorithms. And a couple of other things happened or were happening at the same time, right? So the competition was set up by the Chinese government with a flavor for big data and blockchain. So one of the things that the Chinese government is doing in terms of urbanization is that they are using specific industrial economies to generate specific types of cities, right? So you might have a city which is totally based on logistics or totally based on a particular industry that is either traditional or endemic in a particular area, or they might do it because it has some kind of affinity with natural resources in the area. For example, in the case of Yilong, because it is a city full of rivers, an area full of rivers, you could essentially run big data centers much more cheaply by using hydroelectric energy. Hence, they wanted to create a big data and blockchain city. So by looking at the density algorithm, what we were trying to do, right, we essentially jerry-rigged the density in a way that not only you would get the desired mix of housing and functionality, but instead of, we kind of went almost against what the master plan was asking. So the master plan was asking, create a housing in particular areas, create a more of a CBD in around the lake, and then put the data centers, you know, far away from the city. So what we did is we said, well, you can take the data centers, reduce them in size, put them along with classic functions of the CBD and housing, and then use the energy recovered from the computers to hit the city. And that was the idea that was driving the algorithm, right? So to be able to kind of bring computing infrastructure closer to the housing and normal functions of the city. We ran into lots of trouble on creating the algorithm, and we almost ran out of time. We managed to submit in the end, and we were happy to receive the third award for that one, which kind of gave us a boost on thinking that you could essentially create urban infrastructures to the level where you could run, blockchain nodes at the urban level, and also mitigate against the overheating that they would produce. And then we started to think, well, if we can, combine urban design with blockchain and big data on the level of urban design, why not take this a step further and actually try to see whether we could combine any of the digital tools we were using at that time with blockchain, and what we could do with it. So we did a competition with Davide Lombardi and a couple of our students, and it was at the same time that Wasim Jabi started looking at blockchains as well. And his kind of thinking was, well, there is a, blockchain looks like a database. So what if I take the database that is behind a BIM application and I replace it with a blockchain, right? And to verify, validate his idea, he did something really smart, which was he didn't publish his idea. He made a questionnaire and sent it over to other researchers, and I was one of the researchers that answered back. And he was testing the idea of whether building information modeling would potentially benefit from having a distributed nature, right? And having an idea where you could actually use multiple computers to play with it. And to cut a long story short, right, we started collaborating on these ideas, and I'll take you through now some of the papers, right? I'm sure that everybody knows about building information modeling. I just wanted to show Blender BIM run on this one, right? So this is a school in Scotland, run through the open source version of the IFC solver Blender BIM, and it's very close to what we're working on at the moment. But before I reach that level, let's talk about CAD to blockchain integration, right? We started working with Davide and started to think, on a really simple, basic level, how could we integrate these things? We saw an opportunity to run blockchain inside CAD, and then combine it through the web, and then potentially through an ETH node back then, and at the end actually have CAD run on a blockchain. So I started looking into tutorials on how to do more on the Ethereum blockchain, which was the most easy to work with, but also on tutorials on how to create your own blockchain, which we thought then would be a viable opportunity for us to actually create a blockchain, particularly for CAD designers, right? We did not realize how massive that would need to be, mainly because it's not difficult to actually set one up. The problem is you need a lot of people to participate in it, right? So we first did what you are looking at the moment is a blockchain running inside Grasshopper, which doesn't have a lot of functionality. It's just a proof of concept of our first idea, which was level 1, right? So can you run one on this? It uses Python. You can find on GitHub and online lots of examples where you can use Python to create really simple blockchains with the cryptography that go into them. But also, apart from running a blockchain on your own computer, it doesn't have any kind of functionality unless you're talking to another person. So you could actually, create a blockchain between two different computers and use that to secure some of the designs you might be doing. But it doesn't really scale to the point where you would be able to do something really useful with it on the scale of, say, 300 people, 400 people, and so on and so forth, or even more. So we started looking at level 2, which was trying to connect Grasshopper through the web with the Ethereum blockchain. And you see here a really simple optimization problem running on Galapagos, where Grasshopper is trying to find the highest point on a double curvature surface, and then transmits this to the web. And I would essentially transmit it to another computer on my network running Node.js, which is a really simple web server on JavaScript. And that would then transmit it to an Ethereum node. So you would not talk to the blockchain directly, you would transmit it to a web server. And what we were trying to set up as a model was the idea that you would have CAD designers all over the world being trying to solve a problem. And as soon as they would hit a particular solution, they would be paid. So this is the same problem with a little bit more information on what everything is, how everything works, right? So you get essentially a UDP signal being sent over the web with the transaction, with the number, sorry, to the web server, and the web server is doing the transaction to the Ethereum blockchain. So far, Grasshopper is not touching to the blockchain directly. And our idea was that we wanted to set it up so you have, you're a computational designer, you're trying to solve a problem, you're optimizing it, you send the optimized value to the web host, that is being sent to an Ethereum smart contract, and that one pays you if you are above a certain level of a requirement for that optimization problem. That kind of idea brought forward the idea of collaboration, right? So this was just our first proof of concept to see, well, can we jerry-rig something that would make it easy for us to talk to a blockchain essentially, and then also trigger a payment based on what a designer was doing, right? This is what we were trying to explain. And then we started looking into a little bit more complicated aspects of it with Vasim on board at some point. I know you have Vasim probably on the weekend to talk about Topologic, right? So part of what he's working on is essentially what he calls, I mean, I don't want to steal his thunder, right? He talks about BIM light and about being able to very smartly represent a building with a really low computational footprint, and at the same time do fast analysis and nimble analysis in terms of energy or structure. So he'll tell you more about it. What we were trying to find out is a way to have people collaborate on this. And this is where the blockchain actually made complete sense. So we started looking at a framework for decentralizing architectural design, right? And this is the subject of the paper we published in last year, after we published a couple of papers on this in ICAD. And the idea here is that you have a decentralized autonomous organization, you have a DAO running a design and construction project, and all of the governance takes place through smart contracts on Ethereum, right? And the particular paper looks into the design aspect of it from the optimization side, where you're not trying to create a kind of design from the get-go, right? But we wanted to see how we could create a very specific design problem and then prototype collaboration through blockchains on how to solve it. And essentially, that's what the paper is about. So on a very simple basis, you have a set of, the DAO essentially uses a web interface. Behind the web interface, you have a set of smart contracts that deal with how the problem is set up. And you have an infrastructure that deals with storing the files of the design, but also verifying their authenticity through cryptographically signing them. We use the Ethereum blockchain for the smart contracts, and for storing the files, we use what is called the interplanetary file system, which essentially is a decentralized, is the equivalent of a decentralized storage. If I have to compare it with the web analogy, you know, on the web, you have essentially addresses of where something is, right? So a URI basically tells you if you go there at a particular location, you will find this file. Well, IPFS essentially works by verifying content. So you're looking for a particular content, and it doesn't matter where it is hosted, right? It might be hosted on various computers collaborating between them to host the file. And on the top left, on the kind of Pentagon side, you see essentially the agent, essentially a set of designers who might participate in this problem, and collaboratively or in competition, they are able to kind of create a fantastic army where they can optimize their own designs. On the level of what we were presenting, you have essentially Topologic running in combination with Grasshopper. You might also run it obviously on Dynamo. The web app provides certain coordination points. And as I said, you have IPFS for storing files and the Ethereum blockchain for the logic. I'll walk a little bit fast on what it looks to run the prototype, right? So you launch a blockchain first. You can do that with any of the test networks that are in existence at the moment, but this is what a really simple blockchain on your desktop would look like. And then through that, you deploy the smart contracts on the blockchain. You use IPFS to store a file. And then this is the interface where you essentially get the problem owner registering a problem and their identity. And through that, they are able to start the process. And then the web interface essentially is a representation of what is going on the smart contract level. You have essentially you upload a file saying, well, this is the design problem I want you to work on, and this is being half cryptographically signed and sent to the contract. Then you can open the problem for solutions, and essentially then you can register as a designer. And moving on, then you can work, or you download the problem, the file from IPFS, you load it onto your own software, whether it's Grasshopper, or Dynamo, or Blender at the moment. You create a new algorithm, and then you send that value back. We did create a plugin for Grasshopper that can send information to a local blockchain that you can see here, right? So what this shows is you have the address of the problem, which is the top yellow part, your private key that uniquely recognizes you, how you sign it, and then you can send essentially a value to the transaction. And what happens is you upload your solution as a file, but you also send this transaction to the smart contract. And theoretically, in the end, you record this and you can get paid through this process, as long as the problem owner actually triggers the payment to you and says, well, we're happy with what you're offering. So what we did for this one, we essentially created a new Grasshopper plugin that allows Grasshopper to talk to an Ethereum blockchain. We haven't published it yet on Food for Rhino because I need to change the code so that it talks to public blockchain, and we haven't made it easy yet. But you'll see now how we kind of bypass that. We created a web app that allows multiple billing information modeling software to communicate in a competitive manner, right? So you might have someone working with Topologic, say, on Dynamo, and then someone working with Topologic on Grasshopper, competing to find the best solution. We tested the integration between computational design platform and the Ethereum blockchain directly, right? So you can talk to a smart contract. And I think the most important part was the conceptual and computational infrastructure to enable you to use the smart contract as a regulator of what happens in design. But also a way where we could actually showcase, again, how to recognize value creation in architectural design. So that was the kind of practical part, but then I'll move a little bit more to the theory of how that looks like. We recognize that you might have two modes of collaboration, two modes of operation, sorry. One would be a collaborative one, where you participate in a series of smart contracts and everybody gets paid according to the value they bring to the table. Or you compete and only the best one gets paid. So we didn't see this as a classic only competitive scenario, but we recognize that you might bring value to advancing a design problem. You might not find kind of like the complete answer. In any case, design problems are wicked, right? They don't really have a correct answer or not, but because you contribute to a problem and you contribute to advancing it, you might get recognition for it. I know you're probably going to ask, how do you decide that? Is it a smart contract? And we'll see a case where this is a case where a smart contract decides that, but we can also have humans decide what is your value and what is your contribution to this. In any case, we already showcased that for optimization problems, the competitive scenario is a good case for solving them, right? So you could essentially even now set up a mechanism where if you have particular well-constructed problems that deal with optimization, you can upload all of that on a smart contract platform and allow the internet to solve it, if you might. And this is a kind of visualization that is one of my favorite ones in terms of how we kind of model the problem, because it shows that you can have essentially designers who in collaboration reach a certain level of an inflection point, and this is recognized by the team as a point of value. And the system, the smart contract would note, your creation and contribution for that inflection point. And this is what is beautiful in design, is that you recognize certain characteristics on the solution you have at the moment, and you might completely disregard the rest of the problem and continue only on that track. And this is what the kind of diagram symbolizes, is that through the smart contract, you can, and our mechanism of storing and synchronizing files, is that the best solution through RPFS and the smart contract can be synchronized to all other designers. So if you have, say, 300 of them, 400 of them, or even 5 of them, once someone finds a good solution, that is then available to everybody else to continue working on it. And this is what the diagram shows in the collaborative mode. And down the line, designer number 3 also finds a particular solution that is valuable, and from that point of view, gives us a really good contribution, and so on and so forth, right? This can be continued on if you need to. On a much simpler basis, the competitive scenario means that once everybody finds a better value, you get paid for that moment, and it is irrespective of whether that someone else has contributed to it. which I don't particularly enjoy, but it is a potential setup for the system. And at each point, this is where you get essentially what I was describing, right? You get a design inflection point, you create something original and unique, and these are the moments where you can have a kind of synchronization through the blockchain. Now, I'll pause here if anybody has any questions. If you have any questions so far, we can have a discussion now. I have another 2 or 3 prototypes to show really fast, or we could have it in the end.
Maybe we can address all the questions at the end.
Okay.
Yeah.
Perfect.
Yeah.
So taking this a little bit further, we modeled the kind of idea of decentralized building information modeling, where this is represented by this diagram, where we have essentially a BIM model running on IPFS. You have various user agents essentially change that model. You write to the blockchain only the differences of that model, because writing in terms of full model will be really expensive in terms of gas as a transaction. That's the reason why you don't use the blockchain immediately just to store everything, but you only store particular information that is connected with the smart contracts. And then you can also have decentralized hosts, so you can contribute your computing resources to a decentralized pool that gets kind of grouped together for people to run computation or their building information model onto it. There are already examples of networks that kind of do the computational part. We don't yet have an example where we could have storage, computation, and smart contracts in one. Every time you have to kind of jerry-rig the setup. And just as a, we like not only to do the concepts, but we also try to kind of verify our ideas with simple prototypes, right? So you see here a blend file on IPFS. This one is HAS with SHA-256 HAS, which makes this file really simply, uniquely recognizable on the IPFS storage. And we take this and we create a really simple smart contract that essentially records the difference of the HAS every time the file changes, and a number which is an integer. So you version the file, right? So every time you have like version number 1, this is the HAS, version number 2, this is the HAS. So every time you change it, this simple smart contract records essentially the changes. And that means that you never lose files. You can always go back and really find the file you're referring to, but also find who made the change, which is valuable in many scenarios of big teams collaborating between them. So nothing really complicated, right? Really simple, just to showcase the idea. So that was a paper on DBIM 2020. And this brought us the kind of other idea that we haven't explored yet. We're working on this. When I say we haven't explored, we're working on this. We haven't published it yet in terms of prototypes. So this is a new business model for architects, where you can essentially create, instead of you working on a prototype, as every building normally is, you work on unique digital solutions that you can publish as a BIM model that could be used by everybody else. In a normal case, you would have someone publishing a BIM model, then everybody can use it, even if you have a license to it. But it's not really easily enforceable. You have to, call a lawyer, sue them, and so on and so forth. I might be oversimplifying this, but we are trying to kind of showcase how easy it is for you to essentially publish something on a decentralized storage connected with a smart contract. And then every time someone uses this, you could essentially receive a micropayment. But also, if someone changes it and adds value to it, they also get put on the list, and they receive a recognition either through a token or a micropayment for the contribution they made. So you could have essentially people creating this kind of unique building assemblies or buildings that they get to publish on the internet, and every time someone uses it, you get recognition. But also every time someone changes it, you still get some kind of recognition for the value you created for the next person. So imagine this can create a kind of decentralized, I kind of call it a Spotify for architects, where you not only consume architecture, but you can also create it, and you get to kind of enter into a dialogue creatively with your peers without having to negotiate anything else in terms of knowing them or how they will use it or asking for permission, in a sense. Which brings us back to another example of what we did in terms of collaboration, right? So we wanted to see how easy would it be to set up a DAO. We've published 2 papers on this called DAO Grammars. The first one was called DAO Grammars. The second one was DAO using safe grammars. And we used DAO Stack, the DAO stack of software, to create essentially a set of problems looking back to floor plans for dense skyscrapers, again in Suzhou in China, where you have, again, 3 designers, very convenient, right? We keep it low because we don't have 300 people to test this, but we at least have 3. You set it up, you create options through creating a new grammar every time or variants of this. This is run through a daylight analysis, right? So each grammar gets evaluated in terms of how they're creating a better or worse solution for the skyscraper in terms of daylight. We use daylight analysis because the Chinese regulation is really specific on the amount of daylight you need to have in each apartment. And then that gets uploaded to the smart contract and to the RPFS as a file. And then it's not a smart contract this time making the decision, but it is all of the designers participating on the DAO. So you get a kind of voting into it. And in that, we had a discussion with David and Vasim in the sense that, could you have a democracy in design, right? So could you have everybody having the same kind of weight in terms of how their vote goes? And at least the answer we have is probably not, right? Design is not a completely democratic decision-making approach. You might have someone who is more knowledgeable, so we want to recognize their knowledge. But you also have someone who might have a better invention than yourself, right? So we also want to recognize upstarts or people who come to a design problem from a particular unique and novel point of view. So we kind of set up the DAO in a way where both experience would be recognized in the vote, but also the vote would not exclude unique or out of the box decisions and proposals coming to the fore. And I think I don't believe there is a kind of definite answer to this. It depends on the problem you might solve, because in this particular example, we have everybody participating in the DAO as a designer. But where it starts to become really interesting is if you bring into the mix stakeholders, so people who would want to live in those apartments, the city, right? So city officials, and potentially it is a fantastic platform to solve design problems where, for example, you might want to decide on the location and impact a hospital would have in an area, right? Or an airport, right? So something much more serious where it would allow a much more participatory design process to be established in a way. And again, I'm not trying to prejudice how you would set it up, right? You might, depending on the political situation or the design situation you want to solve, you might set it up in a completely different manner. But still, it would probably be a lot better compared to some of the participatory design decision approaches we've seen in the past 50 years. So arriving then to the thing we're working on at the moment, which is the tokenization of buildings, something that is really fascinating in the sense that it is not just the blockchain enabling this, but actually Topologic itself, right? So this is a kind of the situation that Topologic actually, as an infrastructure technology, allowed us to do really cool things with it. And what we're doing here is that we are breaking down a building into topological entities, which are then all connected. You see the kind of connection on the left, where you say you have essentially 4 columns, 8 beams, and each one of them, as I said, holding a wall or a floor. All of these are topologically connected through Topologic, but also each one of them belongs to a room, and then that room belongs to a building. So you have a kind of topology tree that analyzes the building in terms of where everything is and regulates the geometry. And the good thing we have with blockchain then is that you can create a non-fungible token, not only for the whole building, but for each of the building components. So we published this in CAD which was probably the presentation you saw, and we're working now on a publication that really showcases how we break down a building into all of its components, and then representing that into the blockchain. Now, what that brings to the table is that we are able to create the infrastructure essentially for a circular economy where the information layer is persistent, right? We have essentially Topologic running on Blender with the great efforts of Vasim, who was he's practically working on this every second that he has free. And we're now working on using Blender essentially to showcase how you can take a representation of a building and then store the representation of the building on the blockchain. On the paper we had in CAD, we did this using Dynamo. And then the connector in the end that you see here is run through Python. So you no longer need to have a special component as we had in Grasshopper. You can essentially take the whole topology, run it through a script, as you see here, and then connect it through Python to the blockchain and record it there as a non-fungible token that represents that component. The smart contract is simple enough. I mean, we have, to be honest, we have a couple of versions of it going about. We can see it in the next session next week. And I'll just stop here. So these are the links to Archchain, but also if you look for the organization BIM and blockchain on GitHub. That's where we have all of the prototypes that you can test. And if you look at RLab, that's my personal account, that's where we do all of the experiments. So if you really want the really cutting edge that is also going to make your computer go into fumes, you need to look at RLab. And then I'm going to pause here. So essentially what we're working on now is getting extending this and really, first of all, educating people as we're doing with this session now, but also bringing the tools to the level where they are usable by more colleagues, whether these are engineers or architects themselves. So at the moment, we're working on what further form could tokenization take, right? How does a circular economy work based on tokenization would work, right? could you use tokenization in digital twins? We've started to look into other real-time engines as well, and try to combine them with Topologic and blockchain. One of the things I'm working on at the moment that is still really early on is how can we build collective digital factories for buildings? How can we have crypto economic incentives drive this? How do you set up a smart contract so that you incentivize good behavior in a project, but also not only for the project itself, potentially for wider socioeconomic targets like carbon incentives, right? So how could you try to set up a set of smart contracts and the governance of a project so that you absolutely minimize carbon impact and carbon equivalence through a project, whether this is during design, during construction, and during operations, obviously. And for us, there is a kind of philosophical wider argument of what does a decentralized design and construction process produce as an architectonic product, right? Would it look more like a kind of remix of architectures and styles? Would it have an identity, right? That would be interesting. And some of the questions that dear colleagues and ETA are also answering at the moment, right? How do you create buildings that belong to the commons and operate automatically, right? So you have the chair of industrial construction at ETA with Professor Daniel Hall and his PhD student Jens Huchenwitz, who have already created or are in the process of creating a decentralized autonomous space. So our group is looking at how can you create all of the smart contracts before reaching the level of construction, right? We're focusing on design essentially. But all of these global efforts will end up essentially in the end with having the blockchain as an infrastructure layer for doing design, construction, and operations essentially. So I'm gonna stop here. Let me try. Sorry, I missed.
I see. I must say. Sorry, go ahead.
Sorry, happy to answer any questions. I had set up also a demo, but I think we can take it next time as a simpler case. I would say where we walk through it, from the beginning.
Definitely, yeah. I would like to admit that this was an incredible presentation. Like the examples and the use cases in architecture, construction you gave really helps us to understand what is the potential for it. And I'm more pumped to develop solution. And some of the prototypes and ideas you discussed, like I feel if we deploy it at scale, could revolutionize the way we are working in the field in general. And in the last slide, when you were sharing about decentralized way and who owns the style, it came to my mind, what if there is an evolutionary architectural style where people are selecting the best breeds and it belongs to the people and their selection?
Exactly. You can see all of these kinds of potential operating models developing, and also it makes it fantastic that you could create, for example, an artificial intelligence that would solve the problem rather than you doing it yourself, right? So the good thing with blockchain is it doesn't preclude you working on multiple ways to kind of solve the same problem collaboratively. So I think we're really at the beginning of what this can produce. The potential for integration is massive on a really big level, but also it kind of, by looking at the crypto economics, so looking at the way people might incentivize good behavior, it changes the way you would like to participate in the project. And I think that's where we want to go. We want to go to an architectural engineering and construction industry that is integrated, productive and collaborative, right? And that's where we want to arrive. We're still, as I said, in early stages, and we're trying to publish as much as possible on this. And one of the things I also want to do is publish videos and tutorials so people can use it, right? So how do you set it up beyond what we've done? Hopefully we'll have more on this during the summer. Usually spring and summer is more productive for us. So I see a couple of questions. So there was one by Suze on how are completion and execution of clauses within smart contracts verified? Well, that is set up on the contract and protocol level. So I can answer it really simply. It's up to the programmer on how you set it up. On a really simple basis, if you're trying to record, for example, task for a panel, if you have the to pay for the transaction, then the contract will execute it no matter what. So it won't be an issue from that point of view. If you have more complicated conditions, again, it's a matter of programmatic elegance, if you will, on what the contract will do. But the contract is guaranteed execution every time, unless you have obviously a bug. So that's also a problem. The other big difference with, say, normal software execution is that because the code is public and because everybody can look at it, and it's easy to, it would be easier to exploit it compared to a proprietary code. Smart contract developers pay more attention to security and safety. So they try to make it as bulletproof as possible from a point of view, so that you cannot compromise it. It's not to say that it's uncompromisable. There are still problems with it, and I'll show some of these examples next week. But compared to kind of normal script that you would have, a smart contract is much more stringent and secure, I would say, from its kind of architecture and the way it's written. And then there is another discussion on assuming multiple designers satisfy a condition in a smart contract. Would the remuneration payment be divided between designers, or is it paid to the designer who proposed it first, or any other kind of condition? So on our system, it would be who proposed it first. So if it happened that you would send we didn't test this because it would probably need lots more people to test, but it's an interesting discussion. If both designers send it at about the same time, then it would be a case of who would send it first. And then we go on to a level where we're discussing, it might be who is closer to the node of the blockchain that will receive it first, and so on and so forth. So it becomes more of a, I would say, philological discussion, in the sense that it's highly technical compared to what we want to do, which is we're not talking about transactions in the milliseconds. We're talking about minutes or a more kind of productive and collaborative condition.
Yeah. Thanks, Sujay, for asking this question. I have a few questions on the presentation. So when I was first exposed to blockchain, to be honest, I felt overwhelmed with all the terms. Okay, what is MetaMask doing? What is Remix doing? What is Ganache or Truffle doing? So if you can briefly summarize, like, what are different frameworks and why one should use it?
Absolutely. So let me share again, and I'll share live screen here. So I'll go to Ethereum, and if you go to, sorry, you see the Ethereum screen, right?
Mm-hmm.
If you go to Developers Home, so you can read the docs, obviously learn through tutorials, which are really nice. the two things you need to kind of start playing with is choose your stack, and I'll explain what this means. So you have various ways where you can start developing. The easiest one, I would say, is start with Truffle, mainly because this is a framework that allows you to create decentralized apps with ready-made templates. And this is a desktop tool. So you go and you download it essentially. Ignore Truffle team. This is if you are working with a developer team. Truffle is essentially a set of tools to build smart contracts and a decentralized app. So it also handles deployment to the blockchain and so on and so forth. Ganas is a virtual blockchain. So if I go here, that allows me essentially to run a blockchain on my computer without, and this speeds up development because I can do lots of mistakes really fast. If you try to use, let me try and show you this. Sorry. Really strange. Where did it go? Ah, here. Sorry. There you go. Sorry, it wasn't on the screen. So Ganas essentially allows you to run a blockchain. You see the test I have here, right? So if I go BIM local test, it immediately gives you all of the blockchain accounts you can use. It gives you a mnemonic, which has to do with the particular blockchain. And it also tells you which version of Ethereum it's running locally and where to talk to it, which is this HTTP server. You can also run Ganas from the command line if you are more familiar with it. And then when you do a transaction, it will give you all of the blocks and everything that has taken place, right? So it will, you know, on a low level, it will give you all of the information that you need to do that. But if I go to, where is it? My browser again, one of the easiest ones to develop, which might be a little bit overwhelming. Sorry, classic, I made a typo, is Remix, who is also another framework for development, but that one you can run on your browser directly. You don't need to download it. You can download it if you want to, but it's actually much easier to run here. So the way this works is you'll see some of the tokens I'm working with. You write code, and then you're able to then compile it. I have a mistake here in this particular code. Let me see, 6.2. It gives you a compiler already. Let me try to compile it already. Yes, it worked. And then I can, no, sorry. Yeah, so it got compiled. And then very simply, I can deploy it on a local blockchain, which is running on JavaScript, or it will ask me for my code. And now I am connected through MetaMask to the Ropsten network. So that's a test network, very simply. And then I can ask it to deploy that particular contract. It will ask me Yes, I don't have enough money on my account. So I'll cheat and change to another network where I do have money. And I'll deploy there. So on test networks, obviously you can have, there are faucets where you can request funding. They don't have any value. They're just used for you to test your smart contracts. And that already gives you the idea that you can have, you can run a smart contract and people can interact with it from a test network, and already gives validation to the whole thing. So on a really simple interface, this is what it would look like, right? So this is now deployed, and I can create this particular address, right? So I will put it on the chat. This is the address for the contract I created, and let's create, right? So we will price it as 1 Ether. The token URI would be thank you on your, sorry. Well, I can put a link here, essentially, right? Sorry, and the token will be this one. And we can, I'll leave this as such. I click a transaction, I will now create a token. So we can wait. Yeah, it worked. If I go here and tell me token URI number 1, what is the string? It didn't work. Let's see why. Because the original didn't work as well. Yeah. So I haven't put in a token URI, and this is why it didn't work, right? So, but the general idea is that either use Truffle or use Remix. If you are more familiar with Python, then try to use, so I'm trying to find the framework, which is Brownie. Truffle and Hardhat use TypeScript and JavaScript, respectively. So if you're familiar with those languages, they would be better in terms of testing and everything else. The best tutorials are if you start from Ethereum, and obviously you can also take a look at Solidity docs that has the language, which is the predominant language for writing smart contracts. There are others, but at least for other, I would say it's a good investment if you want to go into blockchain development, because other blockchains will support it as well, like Cardano and so on and so forth. And at the moment, most of the examples you would find are from Solidity.
I see. So the core language is Solidity, and
Yep.
if someone wants to do like compile and test it on a web-based framework, they can use Remix, where they have local testing as well as direct upload it to blockchain. Truffle is
exactly.
for JavaScript-based desktop testing.
Well, it is for Solidity as well, but Truffle allows you. So Remix is bare bones smart contract development. It doesn't have anything else, right? So it doesn't help you, for example, develop an interface. Truffle will also, so if you want to create, for example, an ESOP with a smart contract behind it, Truffle is the way to go. Let me show you the Truffle templates. So I started actually by working with Truffle because it was the easier one to do so. So if you go to trufflesuite.com/boxes, you can obviously create a box on your own, but immediately you have, for example, combinations of, if you work with React on JavaScript for front ends, right, it can give you already the structure with all of the code ready to create something unique where you already have an interface, not only the smart contract. If you're interested more on the low-level applications, and normally this is how we do it, right? So because we have the Web3, we use a Python script on Dynamo and Blender, and then we develop the smart contract on Remix. So our interface is Blender or Dynamo running the Python language, and then the smart contract developer or Remix. But we're also trying now to work where we use Truffle to also develop a kind of state of affairs in terms of the smart contract. So you can create, for example, your own coin with Truffle, with MetaCoin. You can create also applications for other blockchains like Tezos. Tezos has one of the best platforms for non-fungible tokens for NFTs. If you want to deploy something to Azure or AWS, Truffle has those boxes as well. There are what we call layer 2 applications, right, where transactions are cheaper and faster, like Scale. So, if you want more kind of integration with things you already know, look at Truffle first, because they would probably have it on an easier basis. But also it would help you with running tutorials and understanding where everything is.
Got it. So if, for example, someone wants to develop a DAPP of architecture models viewer on the blockchain, they might use like Truffle for creating the front end and having like a viewer which calls the blockchain in the back end and show different models depending on the token. Got it.
Exactly. So that would be the fastest way to do it. Next week in the next meeting, I will show you how you can use Blender or Dynamo to essentially, what we will do is we'll write a smart contract, deploy it, and then we'll use Blender and Dynamo to talk to it and read from it and play with it, essentially. There's going to be lots of success and lots of failure, obviously, because if you don't set it up correctly, right, you won't be able to talk to it. But that's the most straightforward way to do it.
Got it. And one question I have on smart contract is, so I know things get a bit challenging when we are playing with different languages. So like the work in Grasshopper is like on .NET framework using C#, and the smart contract is using Solidity program. And I feel like it intuitively it feels okay if I want to do a Turing complete and terminate based on like, okay, if these conditions are met, maybe like if conditions or something. But if a grasshopper model which has some optimization, like how that .gh file is being read into the smart contract, it like the conversion feels.
It is not. So the way we connect to it is by sending a number or sending a bunch of numbers or strings. So the way you connect it you connect the actual file itself with the smart contract is you take the Grasshopper file, you upload it to IPFS, that is given a unique identity, and that unique identity is being incorporated into the smart contract along with any other kind of number you've set. So you might say, here is a grasshopper.net file which describes a skyscraper or describes a unique bridge. Here is also the IPFS hash file, and the particular file in Grasshopper is also connected with this set of numbers that describe its performance, and be, for example, energy performance. In terms of heating, it might be structural performance, and so on and so forth. So what you will have in the blockchain is the hash of the file, the numbers compared to its performance, connected to its performance, and any other kind of behavior you might want to do. So payments, transactions, or just a record. When you change the file, you will then record again the new hash, the new numbers, and then the blockchain will immutably kind of record all of them until the end.
Oh, I see. So it's the reference we are linking. Oh, because
Yes.
the viewer in smart contract, it might be like, how could I open a grasshopper or a 3D file on a smart contract? Like I can't do like trigger events on, okay, open the file, do computation and give me the answer and check it on smart contract. I will have like a ready results to verify.
Well, you can, it depends on what you set up on the smart contract, right? We can set up a smart contract that could record almost, I mean, we can predict all of the things you want to record on it. If you're using it as a record, then yes. We also have, if you look at Golem, one of the things we haven't discussed and we haven't looked into is a way where we could actually run the computation also decentralized. Because when you're using a Grasshopper file, you are running the computation locally on your machine, right? And you're only offsetting certain certain computational aspects to the blockchain. But Golem, for example, is a network of decentralized hosts that could offload, where you could offload part of the computation to them if it's running in parallel, say a rendering application, and you pay for the computation using cryptocurrencies, and each one of the hosts earns cryptocurrency for the computation part that they're crunching. So as I said, we're still in early stages yet, where we are trying to create this kind of infrastructure for design computation problems.
Nice. Yeah, I'll definitely check that out. And I know like you said Ethereum is moving from proof of work to proof of stake, and one of is like due to sustainability reasons. Like, what are your thoughts on sustainability for blockchain network?
I mean, it's a really interesting problem in the sense that a lot of times you get this kind of I would call them clickbait headers for articles saying, "Oh, Bitcoin is now consuming more than I don't know." It used to be Greece. It's always a failed economy. It's Greece or Argentina or similar. So they're consuming more energy than this country. Whereas you can see that a lot of the mining in certain cases happens in areas that use renewable energy. So I'm not trying to say that proof of work is a good solution to everything, but I'm not certain that the criticism of that people have against, say, Bitcoin or Ethereum is a serious one. Once you consider what, for example, is the environmental impact of, say, crony capitalism or an economic system that is corrupt. So if we compare it with what is going on in other real life situations, maybe it will give us some kind of a better perspective. I still think that if you talk to blockchain engineers that write those protocols, their motivation is to have it run in as a sustainable manner as possible, right? While still securing the system in the same way that provides immutability and provides incentivization for participation. I think we're still, again, very early stages, and we're going to see more competing platforms come for our attention, right? So Tezos is one, as we mentioned. Cardano is another one that is already, from its setup, set up in a way that minimizes energy consumption. You will also see the Polkadot network and Kusama and so on and so forth, which are also designed in a proof of stake kind of idea. So I think if you balance the benefits of what blockchain brings to the table in terms of incentives and participation, and a more democratic participation into collective computation processes, essentially. I think the equation is positive from that point of view. So, but also in the end, it needs more of a nuanced analysis rather than this kind of simple clickbait analysis we see sometimes.
I see. I know we are a bit over time, but I have like last two questions which I
Don't
wanted to
worry,
ask.
we're absolutely fine.
Okay, awesome. And this has been amazing discussion. So, what is your piece of advice for like computational designers who are interested to develop tools with blockchain in AEC space? What are some things or areas they should look into?
I think the first question would be, why go with a decentralized option, right? So you need to consider first, what is the operational model? Does using a blockchain actually help you, or is it more kind of like a fancy option? For us, a lot of times we were in the initial stages, it wasn't clear to us what are the benefits, and there are particular scenarios where the benefits are clear, and there are also particular scenarios where you don't really need a blockchain, right? So as I was discussing, if you are collaborating between 2 or 3 people, the only reason you will use a blockchain if you want someone else to check on what you're doing, right? And that would mean that you're working on a particularly important building, for example. If you are discussing, again, I will take it again on, try to find what is the decentralizing scenario that you want to achieve, and start from there. I would also look into, for certain, Golem, Ethereum as technologies, and see what other people are doing with new things on for example, non-fungible tokens. Decentralized finance is really exciting from that point of view. And to be honest, right, I never was more interested in economics and finance until I started looking into what the hell is going on with these tools, essentially. And then looking at what exactly you want to bring to the table from the point of view of computation, right? There has to be some level of intellectual satisfaction that you're potentially looking for.
I see. And I'm curious to know, like, what's your story of getting into blockchain? Like, what was there any moment you realized, okay, blockchain is gonna be a game changer? Right.
So I started looking into this when I worked for Sian Yatong Liverpool University, right? So before we did the competition, and back then, after setting up the Department of Architecture, I started working as setting up the innovation hub for the university. And one of the things we did is we looked into up and coming technologies that we could base startups on. And it was back in 2015, 16, I think, that I started looking into Ethereum. I mean, we were aware of Bitcoin and what was going on in terms of creating another set of a cryptocurrency, but it was looking at Ethereum and the idea of smart contracts that kind of hit me for the front. And it had to do with 2 things. One was the kind of ability of bringing transparency to supply chains, which in China was a really big question, more so as it was connected with food and food provenance, food information about food provenance, essentially. Where did a certain kind of food came from, and being able to trust the system, right? Being able to trust the system that the information you're reading is truthful or not. And the second one had to do with art and non-fungible tokens already from the point of view of being able to trace them and create this kind of information provenance that is unique. which for a very long time I found really crazy because I grew up looking at the internet as a place where you could easily share information. And from that point of view, in a sense, it was kind of antithetical to the open source kind of idea of sharing. But only if you started to look at it from the point of view of saying, well, I'm still sharing, but also I'm also kind of putting enclosing some value into what I'm doing online. And that is where it started to kind of hit me that it would be really important. So when the competition of the Chinese government came out, looking at big data and blockchain, that's where we started to look into it more seriously and say, well, there is something here that would be fascinating. Currently, I have to say it is still an eye-opening experience, and I'm still learning a lot. I think one of the really cool things that blockchain will bring to the table is more privacy online. So it enables essentially to run things like a social network without having to share your information or have people monetize on it without you getting something back. And the one thing I really want to work on, but I don't have the time, and potentially is my fascination with again Turing and his work is on cryptography, because all of this is based on a really secure cryptographic kind of ideas on that. And I think there is a really architectonic way of looking at how you build signs and you build designs and you kind of create cryptography in a sense is you need to create something that only someone else, a specific person can read it, right? And potentially there are architectonic solutions to this that are interesting. I won't reveal, I was about to reveal a kind of paper I'm writing now, but you'll have to wait until it's ready in October to read it. But I'm trying to work more on the kind of aspect of cryptography and architecture. And obviously, we're working with Vasim and Davide to create more tools for everybody else.
And that sounds quite interesting. And do you have like a utopian or a dystopian vision with blockchain for AEC?
Yes, I think one of the things that we would like to create is more of this vision of collective digital factories, right? So these platforms where people can contribute algorithms and someone else can take it and evolve it. And by having more people, my utopia would be that by having more people participate into it, you create better solutions. And obviously the dystopia would be to end up again in a situation where the platform gets kind of exploited by one or two people and you don't get the value shared between everybody else who participates on it. I think we learned a lot by looking at how the internet developed, where you have essentially this kind of big conglomerates exploiting essentially the information that everybody else participates on.
Yeah, and like one thing I think AEC industry in general I feel a bit bad about is everyone is creating their own in-house generative design tools or some technology instead of like a computer science industry where they have like a software package and it's open source and it grows and you get feedback from the community and improves with update. So I think like with blockchain and with things like Hyper is doing where one could create functions and share it on the web-based interface, that could be really interesting explorations where designers can generate web-based design and upload it on the blockchain, which is connected.
Exactly. So we would see a potential idea where you could have the decentralized version of Hyper, for example, where people contribute to it, and then someone can take it and improve on it. You don't lose authorship, but there is a kind of notion of collective authorship of this. I think the architectural industry is really, the AEC industry is really bad at creating common collective open source solutions. There are many reasons for this, mainly because it's also it's fragmented. It doesn't have the funding to innovate in a sense. If you try to look at looking at tools compared to creation of pipes is a different kind of ball compared to what is our data, right? In an industry like this, takes some time until you kind of realize that you're doing the same problem again and again and again. But most architecture offices or engineering offices are not set up in a way where you could actually take a break and say, well, maybe we need to look at this systemically rather than every time trying to solve the same problem again and again and again. So yeah, I think this is where potentially decentralization might help in those kinds of aspects.
Got it. My last question for this session is, like, you mentioned about resources for learning, and apart from like blockchain in construction workshop, are there any hackathon where students, researchers like you and industry can work and develop solutions?
There is the East Global. So there are mostly from the blockchain side. There is Gitcoin and East Global. I can send you links so you can post them that you can participate on. I normally participate in most of the hackathons for that East Global is doing. There is one running now on which is called Hack Money. We are trying to also set up workshops in conferences. It's a little bit easier now. Well, the kind of silver lining of the pandemic is that everybody's running online workshops, and where you would have trouble for people to participate, now it's easier for people to sign up. So we do have in the schedule workshops to be run in conferences, but we're still waiting for the conference organizers to approve them. So hopefully you'll see us in the next conferences that will come up in September and October and November.
That's awesome. I'll definitely look forward into it.
Perfect.
Thanks a lot, Theo, for your time. It was amazing, and we have one more session next week. So
Yep.
if you guys are watching it on YouTube or part of this discussion and would like to do some hands-on next session, definitely join us.
Perfect. So looking forward to seeing you next week, and let's try to create something wonderful next week.
Awesome. Have a nice rest of your day, Theo. Bye-bye.
Thank you. Bye-bye.
Thank you, Theo. Thank you, Mayur. It was amazing. Though I joined late.
No problem, Richa. Thanks for joining.
Yeah.